Welcome back. I'm here today with Ken Epstein. He's a principal in NewCap Partners. It's a boutique investment firm that they've been doing business in the Asian countries.
Well, we do domestic and cross-border, but a lot of activities in Asia.
So Ken, I want to first start with getting your background established. How did you get up to where you are today? And then I want to jump into what NewCap Partners are working on.
Okay, so I was an engineer originally, and I worked at Dow Chemical Company and moved into, got my MBA and moved into ventures. So I was doing corporate ventures globally, lived in Brazil, lived in Singapore, did a lot of investments in high tech, solar investments, fuel cell investments, water investments, advanced materials for planes, and left the company in 1996 and joined NewCap Partners, which was an investment banking firm. Met them when I was selling one of Dow's businesses. They represented a buyer. So we got to know each other, and when I moved to California, I joined them. And so I've been there, 18 years. And we specialize in working with mainly small companies, micro cap, small mid cap, 10 to 50 million in sales. And we do a lot of strategic partnering. So we work with, I wear the opposite hat. Used to work with big companies investing in small companies. Now I work with small companies and I bring them to the Dows and the DuPonts and the BASFs, the GMs, Toyota, Toray. And so it's the opposite. But I'm used to dealing with the corporates, so it's a lot easier for me to figure out who to work with.
When you're looking at the industry today, and of course this whole, as technology changes, so does the whole economics of business models, but there's something new out there called additive manufacturing.
It's not that new.
Okay.
I mean, everybody says it's new. Actually, go back in history, it started in about 1984. It was for rapid prototyping, and for people who don't know what that means is you make parts, and especially if it's metals or ceramics or something complex, and you're making a few parts. If you try to make it now, you make a casting or a mold, it costs a lot of money. So you figure out how to make a few parts to test it out, and you try to do it rapidly. And that's what they first started doing it, because you make one or two and see if it works. Okay, so it started that way, but it didn't really take off until 2009 when all the patents expired. So,
now that's interesting.
So it's been around a long time. But it was really a prototype tools. And it's still a little bit in that area, but it's now developing beyond that. But it was really what happened is now there was no restrictions when the IP came off, and a lot of people jumped in. And there was a growth demand for alternate ways to make stuff. So yeah, but it's not that new. I mean, it's new because it's now a lot of things have caught up. Software's better, design's better, but patent was one of the issues.
So how is additive manufacturing so disruptive?
Okay, so companies like, there was an IBM study done about 18 months ago. IBM would be one of the last people you'd think to look at additive manufacturing. What does that have to do with computers? But they were looking at how that would affect their data and all that other stuff. And what they learned is, we are, if you're in the manufacturing, we're not consumer, we're talking about industrial, economies of scale. So you have to make 1 million parts or 2 million parts to make economic. With additive manufacturing, you don't have to do that. You can make 50,000 parts and make it economic. Again, we're back to those molds. If you're making, so the examples they used is that they did studies and they said, well, give a couple examples that's disruptive. Okay, well, what if you could buy your car and you have a lumbar adjustment? Well, they only make 6 or 7 of those. You get a car, and whether you're 5'10" or 6'4", the lumbar is pretty much the same. You get the car, and that's it. That can all be through additive manufacturing. When you order your car besides your color, you put in your dimensions for your driver, and they adjust they make an additive manufactured lumbar part. That was one of the things they said that's going to happen. That's one of the parts that it makes all the sense, because you don't need molds. I mean, one of the problems with making that is you make $50,000 to $100,000 molds to make the lumbar, and you can only make so many molds. So this restricts what you can do for design. Additive manufacturing doesn't need a mold. You put in the computer design of what the body is, and when you do the car, you just make the mold, make it.
I'm visiting here today with Ken Epstein. He is one of the principals in NewCap Partners, and we've been talking about additive manufacturing and also some of the trends in the industry. Ken, I need to take a quick break, and we'll be right back after these messages. More with Ken Epstein.
I love fishing, with my family.
I think it would be easier to use a net.
It was so much fun.
The times when we are together, it makes it all the more worth it.
Having Dad teach them how to cast a fly rod, and
as long as we're doing stuff together, we're having fun.
Some people see a father and a son fishing together, while others see a succession plan.
Welcome back. I'm visiting here today with Ken Epstein. He is a principal in NewCap Partners. It's in a boutique investment banking firm, and we've been talking about additive manufacturing. And I want to jump into this. It's a term that, as you said earlier, has been around since 1984. Yet we're just coming into understanding this better. Some people say, well, 3D printing is part of the additive manufacturing. But when we look at specific industries that are affected dramatically by additive manufacturing, which industries would those be?
Well, we see all these printers at $1,500 or less, and there's over 100,000 printers out like that now. And we see them for toys and consumer goods. But that's not really where the large value is. I mean, it's happening, and people can now design their local stuff. But I mean, you saw the example of making a gun. Well, they're actually making guns, manufacturing for real guns based on additive manufacturing. They're doing prostheses and other medical parts, as you can imagine. One of my clients makes implants. And the advantage of 3D or additive, you can make the implant for a knee, and you can make the holes perfectly and put injectables in there for release for pain, which you can't do with metal. So it allows you to do something to integrate not only the part, but also to minimize the number of times you have to go in for treatment for shots.
Now, we talk about all these sophisticated or specialized industries, but a couple weeks ago I was in a sporting goods store, and I saw on the tennis shoes 3D printed. And I'm like, are you kidding me?
Okay, so one of the conclusions there is, if you look, when we buy shoes or sneaks, when we go in, there's only so many sizes you can get. That's because of the molds and the cost of doing that. 3D printing allows you to make shoes to fit almost anybody. You can just design it. You go in, just like you get your inserts for your shoes. You just you can go in, measure them, and then print them. So we're going to see a lot more. That's one of the shoes and sneakers are going to be one of the big changes with 3D, because you don't need a lot of capital. And so we're going to see that. You're seeing it in bicycles. You're seeing it in equipment, sporting equipment. Those are already going. So life science, some furniture parts.
It's interesting. So we're really on the very leading edge of additive manufacturing, what it will become.
Right.
But what are some of the advantages or disadvantages to this industry right now?
Okay, so the advantages over traditional, one of the things is we're always limited by design. If we're going to make anything, because we've got to have a way to make it over and over again. Additive manufacturing allows you to make almost any kind of shape. And so you're going to see big advantages. You don't have to be stuck with certain shapes and sizes. In fact, that's actually a problem, because the designers don't think that way. They think, well, once we got it, we're going to do it. But with additive manufacturing, you can make all kinds of shapes. And now you have to think a little bit differently. It's three-dimensional. And so you can think outside the box for design. More complex, 3D doesn't have that problem. So if you need a complex shape or a design, That's why the toys and flower arrangements and medical equipment and any kind of furniture, you can shape stuff that you can't afford to do otherwise. Otherwise, you have to do a lot of machining or cutting or whatever. Just make it shape. So that really works away. Customizing it, reducing time to market, and short-run production. Those are the real benefits.
I'm visiting here today with Ken Epstein. He is one of the principals of New Cap Partners. Ken, we need to take a quick break, and we'll be right back after these messages.
When I grow up, I want to work with very successful people.
I want to advise people so that they can pay less tax.
Hang out with my clients on the golf course.
Fishing.
And on their private yachts.
They will all be my friends too.
I want to work with the VCs who will fund the next Fortune 500 company.
When I grow up, I want to be just like my dad.
Money won't buy you happiness in life, but we can help take care of your financial affairs so you can focus on what's really important.
Welcome back. I'm visiting here today with Ken Epstein. We've been talking about additive manufacturing. Ken is one of the principals of New Cap Partners. It's a boutique investment firm, and they help to take small companies and develop them into the point where they can roll up into larger companies. Or looking at how to really help some of these companies expand. Now, Ken, we've been talking about 3D printing. What can you tell us about the stock collapse of 3D printing companies?
All right, so Stratasys and 3D were the hot items, and they went up sky high. Here's what you have. 3D manufacturing is a tool. Instead of being valued as a tool, it was valued as the breakthrough. It really is a tool to make parts, and the tool has to be straightened and arranged to make the exact parts. So there was no pull-through. There was no application driving it. It was a selling of tools like a printer for home use, but you had no applications. You weren't, there was no big market driving it, so it was ahead of its time. So what we're seeing now is a lot of the consumer and industrial parts that didn't have the application are coming through. It's taken 5-7 years. There was a meeting in September in Europe where they announced 200 parts for aircraft, including the 777 Boeing and Airbus, all 3D. Well, it's been in 7 years in production to get it qualified. So we were ahead of the cover. I mean, so basically, are companies that were 3D printers going to be the success? Don't know. Maybe the end users using 3D printers. The other thing, the business models changed. We're going to see the Kinkos of the world, our equivalents, where you go in and get 3D printed. You go in and just like you print your stuff, you go into a place and they have 6 or 7 3D printers and you say, this is what I want, and they print it. Well, that's not driven by the printers. All the ones we were talking about that were on the investments were printers. That's not the money. Just like HP makes its money on ink, not printers, that's what we have. It's going to be in the application and the parts, not the printers.
So as we go through this process of evolving, where do you see the biggest growth of additive manufacturing industry coming from?
Well, it's going to be, it is short and long term. You have to look at this and say the consumer market and life science, home building parts, some small metal parts for, industrial, power tools, maybe some shoes and other stuff, specialty parts is what is happening now. But where it's looked at is more industrial. Aerospace is starting to use it, and we're going to see more. We're starting to see auto test it, but that's 4 or 5 years away. But the large volume is a change in materials. Where you see the toys, they're using ABS, just standard plastics. You produce it, and you can buy these very cheaply and just make it, right? But where the big value is metals, ceramics, high-end thermoplastic materials, which are much more costly and they have much higher value in their engineered properties. And GE's got a big ceramic activity for industrial, for turbines and for planes that's ceramic, 3D. They bought several companies because it saves on machining costs and saves on all that stuff. So they're having parts going through the system. Boeing's putting it on their planes. Satellites are starting to use it. Autos are starting to look at parts. So I think we're 4 or 5 years away from the big volume, but the specialty volumes for industry are just starting to come out. You'll start seeing parts announced 2016, 17, 18. So the hype got ahead of the cover. We're going to start seeing some really good parts come out for all kinds of applications besides just toys and simple retail consumer goods.
When we look at the future of additive manufacturing, do you see the bigger play all the way down to the consumer market, or do you really see it staying up at the manufacturing and
has to be both if
okay.
it's going to be successful. I mean, we're looking at 2012, we hit $2 billion if you want to look at additive manufacturing. Before 2009, it was a speck. Okay, it grew 30% to get to 2012. It jumped to 2015, you're in $4 billion, so it's still not growing. It's growing 20-30%. Estimated from 2015 to 2017, it's going to double or go up 50%. And then 2020-21, we're going to be seeing $10 to $15 billion. So you're going to see retail, you're going to see consumer, you're going to see industrial, and you're going to see some larger volumes. Now, the biggest problem with additive manufacturing is size. You're restricted on what size you can make. So the largest part may look like a computer. That's, a portable computer, maybe, 3 feet high, 2 feet wide. That's as big, but complex, but that's a big restriction. So one of the things holding it back is how big a size you can make. And you can make complex shapes, but making the size. Inspection, QC. Again, we're talking for toys, not a problem. But if you want something functional for furniture or medical, you need to have much more understanding of it. And the material knowledge. It's still a printer. It's the materials combined with the printing that really makes a difference. So that's holding it back. But they're getting better at it, and you're gonna, like you said, you're gonna be able to go down a contract, and they'll say, which materials do you want to use? Well, you won't know. So I said, I want to make this part. What material should I use? And then they have to fit it to the tool.
Who are the leaders in additive manufacturing right now?
Well, there isn't. I mean, all the names you hear, HP and Stratasys and 3D and EOS, those make the printers. But the ones who are driving the market are the end users. So the players that are in the driver's seat are the ones that are pushing the parts. They're going to make the parts, and the printer is just part of the process. See, it's the chicken and wagon. We're got the horse in front of the cart now, and now we're going the right direction. But before, the printers were trying to drive it. There was no market. So in aerospace, it's Boeing. It's auto's still early, so we're still not sure. In furniture, there's a whole bunch of furniture stores, and there's a bunch of medical companies. There's a little company in Connecticut who's a client of mine, and Oxford Performance, and they're the leader in medical for 3D. I mean, medical implants. They're the number one player in that. One of the players in there. So we're seeing small companies starting to grow, and we're seeing some mid-sized companies, but we're also seeing large companies using it. So a lot of people are looking at it. Anybody in materials has to look at additive manufacturing. Anybody in manufacturing has to look at it as another process, but it isn't a cure-all for everything. It's volume is still a problem. You can't make large volume, but you can disrupt medium-sized volume because you can make a 3D without the cost.
So if someone wants to get in touch with you at NewCap Partners, how would they go about that?
Okay, so my email is Epstein, E-P-S-T-E-I-N @newcap.com, and my phone number is 650-631-0787, and we have 3 additive projects going now.
We've been visiting here today with Ken Epstein. He's one of the principals at NewCap Partners. Ken, thanks for being on today's show.
Thank you.